star finder that could set your sky up and tell you where stars are, not in relation to each other as constellations, but in relation to you in terms of bearing and altitude. This star finder can be set up by a 5th grader or older with ease and only take 2 minutes to set it up. It's a logical star finder in that it has a base disk that has all the information around the outer perimeter, such as you might see here. It has degrees starting with 0 and continues to 360 degrees back. You're actually looking at the northern hemisphere and the Earth when you look at this. The Earth is actually in the very center, but all these bits of information are radiating out to the outer rim. So you have time, degrees, and you can set stars up using these bits of information. A closer look. Notice the times on it are in Greenwich Mean Time. What that means is the time on your clock plus, if you're in the Western Hemisphere, or minus if you're in the Eastern Hemisphere. So this will give the time at Greenwich Mean Time at Greenwich, England. And this happens to be where Greenwich, England is. Notice degrees and time. We'll go into those a little more later. Also, the star finder will have your position and your sky with bearings around the outer perimeter, 0 through 360, and also the height of anything that enters this grid, so that you can read off the bearings and the height once you set up the star finder. On the star finder, you will place and position a group of stars, and the stars are locked into place and travel by what's known as the first point of Aries. So your job will be to set up first your horizon disk, then the first point of Aries. This should take you under 2 minutes with no outside source and a very small addition. Along with the star finder, you would also receive complete instructions as to its use. Once you've accomplished the setup a few times, it will not need any more instructions, and you should be able to set things up with grade A ease. So we'll do a problem on the star finder and show you how it's done. The first step would be to set up the horizon disk. This is that spider web that you see on the disk, the main disk, with the figures on the outer degrees. We selected the spider web for our latitude of 41, or closest latitude of 45. So this disk is the disk for 45 north. There are other disks that may be in different areas, but all you need is your local area. So this is 45 north. You're actually located at 41 north and 71 west on Earth. Now the X in the center that you see, center of the spider web, is actually your position over your head on our Earth. You may see where that pin is in the center. You can see the latitudes such as 20 degrees, 50 degrees, 60 degrees, 70 degrees, and right on down. On that spider web you can see 10, 20, 30, 40, 50, 60, 70, and so on. So any star by name, you can see a few of them here, that enters this spider web, you can read off their bearing and their height above the horizon. The star that we're looking at is at 0, 4, 8, or 7 bearing, and a height of, say, 12. That's the thing you want to do. Read these names and the height of the star. When you look up in your sky, you're going to see these stars at these bearings and these heights. So let's set up a problem so that we can see how to put these stars in our sky when we want them in our sky. The first thing we do is look for the date and month on the outer rim. In this case, we're going to do an example of July the 12th, which means July on the rim plus 12 degrees. Each degree is 1 day. June, July. So 12 of those digits are right about in the center right now of our camera. Now what we do is read the time where that 12 days appears. You can see the 7 o'clock. Each degree along the outer rim is equal to 4 minutes. So if we count to July the 12th, the 12 degrees out, and each one of the degrees are 4 minutes, we can determine that the time is 07:24. So now that we know the time, we have to decide what time we want to actually go out and look at these stars. So what we do is determine that time, and let's say, for an example, we want to go out at 23:15 Greenwich Mean Time to observe stars. Then we add those two together, 07:24 plus 23:15 equals 30 hours and 39 minutes. But there's only 24 hours in a day, so we want to put Aries, which is the star disk, on 0639. So let's look for 0639. It happens to be very close to that time 7. So we put our first point of Aries on the star disk at that point. Now, we have our stars in place, we have our longitude in place, and now we can look at the stars in the sky and we can read off bearings and height and write them down and go out and see these stars' bearing and height from us. In the center of the screen is the blower at bearing 235, altitude about 52. Another star, Regulus, bearing 257 with an altitude of 32. You can see stars that are just coming up above the horizon. You can see stars almost due south of us. There's Specker. Specker's bearing 180 plus 8 more, so 188. The altitude is 37. So we can make a list, or we can just go out and look at stars. And it only would take us 2 minutes, once we've done it a few times, to set this disk up so that we can see all these stars. So this is a 2-minute